Okay, so welcome back to this lecture. In previous lecture, we have already seen the fundamental of regular expressions. In this lecture, we are going to practice few more regular expressions. So let's look at the very first regular expression which I have written here. There is a regular expression for an empty language. So I think we have already seen empty language. The regular expression we write like 5. Okay, regular expression for the languages containing only the empty string. So if a language is empty, it is 5. If a language is containing empty string, that means it is having at least epsilon inside it, so that will be the regular expression. A regular expression for a language containing a single specific character, that is a. So if a language is containing only one character, that is a, the regular expression will like this. Regular expression for a language containing either a or b, so you can write either a or b. There are only two strings like this. Regular expression for languages containing any combination of a's and b's including empty string. So that is very easy, we already know any combination means clean closure of a or b, right? The regular expression of a language containing one or more a's followed by one or more b's. So first all the a's will should come and then b should follow. Okay, one or more a's. So you can consider this language like a to the power n, b to the power m, where m and n greater than or equal to 1. But remember, there is no correlation between m and n. So there is nothing like mentioned m is equal to n or m greater than or m less than n, nothing like that. Then this language is a regular language. So if we write it like a positive closure, b positive closure. So a may come 2 times, b may occur once. So there is no comparison between a and b, but there is a surety that first all the a's will come, then b follows. A regular expression for a language containing 3 consecutive 0. So if only one string 3 consecutive zeros this language is containing, then it will give you like this. So 3 consecutive 0, right? It will give you 0 0 0 only, one string. But let's say another regular expression for a language containing either dog or cat. So if D is a legal literal, G, this is a legal letter D O G, let's say. The alphabet of language may be A to Z, or cat if you want to write. So we can write a regular expression like this in automata theory. If you want to write this thing in let's say C programming, when you want to write regular expression for lecture, or maybe you want to write such kind of regular expression for on Linux scripting, so you can write something like this: dog, you can write something like dog and this pipe symbol or symbol, and then let's say cat. Okay, so it depends upon the environment, but the fundamental is same. Then the next language, regular expression for a language containing a binary number without leading zeros. Without leading zeros means a number should not be started with 0, right? So if a number should not be started with 0, because this is a binary number, it must be starting with 1. But after that, it may have 0 or 1. So there's not a problem after that, right? Then this expression, regular expression for a language containing a valid email username, no special character. So this is easy case. If there is no special character, only username. So you can say A to Z, and let's say if you are allowing numbers also, then you can write 0 to 9 numbers, and you can put this thing inside the square bracket. Square bracket means it is representing single character. Okay, if there is no restriction on the length of this, I can put positive closure on this. So at least one length username you can set, or two length and number of length you can put. If there is a restriction like your username need to be at least 4 character long, 8 character long, then we cannot write like this. We need to define 4 different places. So if I assume that this username at least should have 4 character. So then the very first character I have defined, like it can be either A to Z or 0 to 9. Similarly, next character can also have A to Z or 0 to 9. Similarly, next character can also have A to Z or 0 to 9. Similarly, fourth character can also have A to Z or 0 to 9. And I can put plus here. So at least 4 or maybe more, right? Then regular expression, this is containing a valid floating point number without optional sign. Okay. So if it is having a floating point number means something like 9 point something something something. So if it is specifically focusing on the floating point number, how we can represent the floating point number? So if we want to write this regular expression in, let's say, Linux or for Lexer and C language, floating point number, we can say a number which can have a sign. So if I write it may have plus sign, I'm considering plus is a literal or a symbol. Okay. And if I'm writing for Linux or C program, then I will use this pipe. Otherwise, I can use if I'm writing just for automata theory or something, then there will be different representation. So this may have 0 or 1, right? Or I can use single place for this. So I may write something like this. One character should be either plus or minus. So I'm closing it inside the square bracket. That means I'm defining the very first character as positive or negative. Then here I may represent like 0 to 9 may occur. So I may fix it like it should occur once. So I can fix or maybe more times. Then I need to have dot. In some of the languages, dot have some specific meaning, like dot specify a single character. So if it is having some specific meaning, special meaning, to remove the impact and to treat this dot as the dot character only, we use that escape character. So we consider this is a escape character, the backward slash. So this backward slash will help us to treat this dot as dot only. And then after dot, we again have 0 to 9 a number of times. So this can be one possible regular expression which we can use either in Linux, or you can say for Lexer we can write such kind of regular expression. Okay. Then regular expression for language containing a valid date in this format. So date like 4 digits, then 2 digits, then 2 digits, and separated by hyphens or minus sign. So 4 digit like 0 to 9, the very first digit can be second digit. If there is no restriction, I am treating. Second digit can also be 0 to 9. Third digit can also be 0 to 9. Fourth digit can also be 0 to 9. Right? And then hyphen. So after hyphen, again the same thing. I need to define 2 places, month. So if I want to fix the month like 1, 2, 3, 4 till 12, I can write by putting or symbol in between. Or in general, if I am not putting any restriction, the month will be either 1, 2, month cannot be 0, month cannot be 13. So I can write either 0. So I do not write like this. I may write this place as 0 or 1 or 2 or 3 and so on. I think you know that. And 12. So this will define this particular place. What is coming here, here. And after this hyphen. After hyphen we need date. So date can be from 1 to 31 or so we can again write. Okay, so here 0 should not be there because month cannot be 0. So 0 should not be there. 1 to 12, right? Date can be 1 or 2 or and so on till 31st. So according to the situation, we can write the regular expression and we can test it in our application. Whether you are writing the code in PHP or anywhere, you need to test it. Now regular expression for containing strings with an odd number of A's. So this is easy, like odd number of A's if you want to write an automata. So odd number of A's, you ensure that at least one A will be there. Okay, and after that there will be consecutive A's will occur. So odd number of A's, that means there is no restriction on B. So B may have n number of B's, but A will have odd, so I am saying there may be B, and if I write something like this will give you odd number of B's, because one A is confirmed, and whenever you repeat this, again the even times you are adding the A, so overall A will be odd. Then if you consider regular expression for a language containing a string with an even length of B, so even length of B is like this. Even can be empty also, so it can be even length of B is like A, there is no restriction on A, but B should be even, so I may write A loop B and I can repeat it, so it will have even length, right? Regular expression for a language containing all permutations of A, B, C. So if a language is containing all permutations of A, B, C, that means what will happen? If A, B, C, like all permutation, there are three places, then the all permutations will be either A, B, C or A, C, B or B, A, C or B, C, A or C, A, B or C, B, A, right? Regular expression for language containing strings with at least two A's. So a string with at least two A's, it is not that difficult to understand. That means there is no count on 0. So if I write like 0 asterisk 1, 0 asterisk 1, and if I put plus over this, I can put 0 here as well. So there's not a problem. This is star 0. This can ensure the thing. Then the next one is for a language containing strings that start and end with the same symbol. So start and end, that means if A and B I am considering two symbols. So if I am considering it is starting with A, ending with A, in between A plus B, anything can occur. Or starting with B, ending with B, in between A or B, anything any times can occur. Or it may have single A or it may have single, because if I say A is starting and ending with same, B is also starting with ending with B. A regular expression for a language containing strings with at least one A's and one B's. So at least one A's and one B's, the meaning is at least one A means and one B means B star, right? So at least one A and one B need to be there. The rest anything can occur. So if you don't want to write like this, then there's another way also. You can write either A or B, positive closure. So it will ensure at least one A or one B, or, but here if it is and, we need to restrict that. At least one A should occur and one B should occur. And so both should occur. That means I should write like A star or B, A plus or B plus kind of thing. Okay. So I can write something like this. If you want to create few more things, like if you want to write something else, A or B followed by star, if you write, that is also fine. So I hope these example will help you to understand the regular expression and how to write a regular expression for a given language. In next lecture, we will see how you can convert an automata to the regular expression, how a regular expression can be converted into automata, right? There are two ways. We can use Arden's theorem, and the elimination of a state is also one of the way. So see you in the next class. Thank you, everybody.